Hello and welcome to Otten Math. Today we're going to talk about arithmetic and geometric series. We're going to define what a series is and relate it to a rule. So let's go back and talk about sequences first. So if you recall from our prior two discussions in discussing recursive and explicit rules, sequence is a function whose domain is a set of consecutive integers. Typically that domain starts with 1. And it can be a finite sequence, meaning the domain inputs will be finite or limited in number, or it can be infinite, meaning the domain starts with 1 and goes to infinity. So the output is going to be the range, and the range in the sequence, the values are called the terms of the sequence. So again, in an infinite sequence, we have an infinite number of terms or outputs, and in a finite sequence, there are a finite number of terms. Right, so what a series is a sum of the terms of the sequence. So remember, the terms are the outputs of the sequence. An infinite series has an infinite number of terms. As we mentioned, a finite series is a finite number of terms, as we've mentioned with sequences. Today we're just going to talk about finite arithmetic and geometric series. Right, so arithmetic series, the formula is going to be S of n, which is the sum of n terms, is equal to n, the number of terms, times a sub 1, the first term, plus a sub n, the last term, divided by 2. So all we're really doing is taking the average of all of the terms with an arithmetic sequence. Remember, it has to be arithmetic in order for this rule to hold. We're taking the first and last terms, dividing by 2, taking the average of all of the terms, and then multiplying that by the number of terms in the sequence to find the sum. So I'm going to leave this up for a moment while you copy it down. All right, so let's do some classwork problems. All right, so we're going to take a look at this table here of values, my input domain, 1, 2, 3, 4, 5, 6, 7, so consecutive integers starting with 1, output, my terms, 2, 3, 4, 5, 6, 7, 8. Now I want you to use the rule to find out, first of all, you have to answer the question, is this arithmetic sequence? And the answer is yes, there's a common difference of 1 between all the terms. So we know we can use the arithmetic sum rule. It's finite. I have 7 terms, so let's have you use the rule to figure out what the sum is, and then you can compare the values by just adding the terms together. Okay, so this is what you should get. S of n is equal to 7, the number of terms, times 2, first term, plus 8, last term, divided by 2. So 7 times 5 is equal to 35, and we can compare that by just adding the values 2, 5, 9, 14, 20, 27, 35. So we can see that those two sums match. All right, so let's do some classwork. Find the arithmetic series. So S sub 10, A sub 1, sometimes I use T as well. So T sub 1 is 3, T sub 10 is 39. I'll pause while you figure this out. All right, so we have 10 terms. First term 3, last term 39, 3 plus 39 divided by 2. Is going to be 21. 21 times 10, number of terms, equals 210. All right, next one, find the arithmetic series. I'll pause here. All right, 18 plus 40, 472, 490 divided by 2, 450 multiplied by 200 terms, ends up being 49,000. All right, find the arithmetic series here. Okay, the first thing we need to do is we need to find the common difference. Common difference is 4. And then we need to find the number of terms between 99 and 3. So we subtract 3 from 99. That's 96. Divided by 4 is 24. So we have 24 terms between the first and the last term, which means we have 25 terms total. Have the first and last term, 3 plus 99, divided by 2 is 51. 51 times 25 is 1275. All right, so let's talk about the formula for geometric series. Geometric series, sum of all the terms in a geometric sequence. And remember, geometric sequence has a common ratio between all the terms. That common ratio is the subsequent term divided by the preceding term. So S sub n is the sum of the n terms of the sequence. A sub 1 is the first term. R is a common ratio. And R cannot be 1. If R is 1 in this case, then you end up with 0 in the denominator. And you'll end up with an error or an undefined value that you're multiplying by a sub 1. All right, so I'm going to let you jot this down. All right, so find the geometric series S sub 20, given t sub 1 is equal to 1, r is equal to 2. All right, so S sub 20, a sub 1 is going to be 1, r is going to be 2, and n is 20. So S sub 20 is equal to 1 times 1 minus 2 to the 20th over 1 minus 2. And you end up with 1,048,575. Okay, next one. Now I have t sub 2 is equal to negative 6, t sub 5 is equal to 162. I want to find S sub 20. All right, so a couple things we need to do here. First, we need to find the common ratio. By the way, for my students, you need to have strongly recommend that you have a strategy of finding the common ratio for problems like this where you're given two terms, one of which is not the first term, to find the common ratio. So t sub 2 is equal to, in the formula, t sub 1 times r. T sub 5 is equal to t sub 1 times r to the fourth. So I can rewrite both of those equations for t sub 1. So t sub 1 for the first equation is equal to negative 6 over r. And the second equation, t sub 1 is equal to 162 over r to the fourth. If I set those two equations equal to each other, I end up with 6r to the fourth is equal to 162r. And then solving for r cubed is equal to negative 27. R is equal to negative 3. And I can simply back out t sub 1. Negative 6 divided by negative 3 ends up being equal to 2. So now we have everything that we need in order to write in the values for our geometric series. T sub 1 is equal to 1 times t sub 1, sorry, S sub 20 is equal to t sub 1 times 1 minus r to the 20th over 1 minus r. So 2 times 1 minus negative 3 to the 20th over 1 minus a negative 3. And so you also in this problem, you have to remember your order of operations. You can see that the numerator ends up being a negative value, and the denominator ends up being a positive value. So the overall sum is going to be negative. If this were to the 21st power, then you'd end up with a positive value. You'd have a negative over a negative value. And so actually the terms of the sequence, the sums are going to go back and forth because the terms are going to get larger and larger and cover basically the values, the sums prior to that subsequent term. And so if you use the 21st power, you'll end up again with a negative series or sum value. Okay, that's it for this edition of Ought in Math. Thanks for joining us as we talk about arithmetic and geometric series, finite rules, by the way. Tomorrow we're going to start talking about infinite series and rules for infinite series. Thanks very much for joining.